Hello, everybody. Good morning.
Good morning.
And welcome to our session. Thanks for joining. In this session, you will learn about how to get started coding with EclipseStore and how you can build ultra-fast in-memory database applications with pure Java for microservice architectures, and how you can build such systems that scale horizontally, elastic scaling in the cloud by using Kubernetes under the hood. So my name is Markus. I'm CEO and co-founder of MicroStream, and together with Christian do this talk today.
Hi.
I will give you a short introduction, just some minutes, and then Christian will jump into code and we'll show how to get started coding with EclipseStore. So we, with our team, work on Java for more than 20 years now. We have experience in IDE development, so we worked on a Java IDE. We worked on improving and simplifying JBoss Hibernate tools on Eclipse, and then we started, so almost 10 years ago, started the MicroStream project. We open sourced it, so we work on various open source projects, and now we are super happy to announce that MicroStream is now not only open source, it's split it into two Eclipse projects, and one is Eclipse Serializer, and Eclipse Serializer is also the core of EclipseStore. So Eclipse Serializer is already now available as a final release, and we're still waiting, I'm sorry for that, still waiting for the final release for EclipseStore, but you can already check out the first and the last milestone release for EclipseStore, so you can use it already. And it's bulletproof, it's used in production already for many years by companies like Allianz, Fraport, and other bigger companies. It is well integrated with Helidon, thanks to the Helidon team. And also, sorry for that, David, it's also integrated with Micronaut, so we have also great integration with other frameworks, and more frameworks are using EclipseStore. What is EclipseStore in a nutshell? So it is a kind of like magic. So we had in mind that persistence actually should done by the environment. So because of persistence is complicated and leads to high complexity, and actually we should not care for persistence. This would be a developer dream actually. So just focus on business logic and don't care for how to store objects in Java. So we thought that really the vision come true when Intel introduced persistent memory. So this would be approach that the hardware infrastructure cares for persistence, but this works different. And so we worked on EclipseStore, that EclipseStore cares for persistence, and now the framework is ready. This is not a functional principle that we invented. So the functional principle is known for many years. Banking companies and gaming companies do it for many years already. So building these high-frequency trading applications, because of databases are very often too slow, so they build these in-memory systems. Everything runs in memory. Everything is done by Java because it's fast. And to get persistence, to be able to store their data, they have mostly to build their own in-memory database systems. And this is effortful and expensive, of course. So we cannot do this in all business applications, unfortunately. But now with EclipseStore, we have a framework, and you can use it. And this works really simple. So it adds persistence to Java. So, and is an engine that allows you to store any kind of objects, any kind of Java objects, any complexity, any size, persistently into any data storage. And we use the Eclipse Serializer for storing the objects in a binary format, so the format is open. And vice versa, when you start the application, you'll be able to load any stored object structure and restore the object structure in the memory again by using lazy loading. So you not only can store the entire state of your application, mostly, so in practice you will never restore or restore the entire state. We mostly in practice store only the changes. So you can store subgraphs and you can load subgraphs on demand and keep hot data in memory. So keep your data in memory, your objects in memory, and browse through your objects by core Java. And so this will be very fast. Faster than traditional database systems. Who of you have ever heard about MicroStream last year or EclipseStore already? Okay, some of you. Give me 2 more minutes, Christian, please. Sure. Here is a functional principle. You can see an architecture. Normally, we have, of course, a JVM. We have some objects in memory, and we have a database. The problem is we cannot store objects in a database, so we need in between an object relational mapping, and this is pretty much the same when we use a NoSQL database, because we cannot store any kind of object structure in a SQL database, NoSQL database. So we need a kind of like mapping or data conversion in between through every single read and write. This is very expensive and slows down your application. So what we are doing in practice, we add a cache normally, then we have so issues with cache configurations, and in distributed systems, mostly we have a cache in between the application and the database, so we very often run distributed caches, so the architecture gets more and more complex. So, and with microservices, we have another challenges because of each microservice that stores data should have its own database. So there are a lot of different database systems used in microservice architecture. So if you store sensor data, use a time series database. If you have complex data, use a graph, and so on. If you have unstructured data, you use mostly document-based, and so on. So multiple database systems, this increases also the complexity of your system. And databases are very expensive in the cloud. And so this is the reason why we changed this with EclipseStore. Here we focus on core Java, because we know Java is very fast. Everything that you build in Java is executed in memory in microseconds. So if you search and filter data in memory with Java, we talk about microseconds. And we have a great great data structure. We have a multi-model data structure already in Java. So we have object graphs, can use collections, all Java types, simple list, store single values or single objects, or complex object structure with circular references. Everything is possible in Java. Also vectors. So we don't actually need a vector database in Java. We can do this with core Java. Searching with Java Streams API. If you search an object graph in memory, it will take only microseconds. So this is the reason why we always talk about 1000x faster than a comparable JPA query. Here we talk about milliseconds. So super fast. And the question is how to store data. With EclipseStore, now you can store your objects very easily. All right, so very important. You have to think different. This is a paradigm shift in database programming. It's because of there is no more database server. So your object graph in memory is now an in-memory database. We search in memory, filter in memory. We don't query a database on a remote server. There is no more database server. So keep this in mind. In this architecture, last minute, I promise. So we replace, you can see we replace object relation mapping or data conversion with EclipseStore. We keep data in memory, search in memory, so we don't need a local cache anymore. And from a database, so our business logic cares for everything that is provided by a database actually. So for logging, locking, validation, user management. So we can do everything in Java, and mostly we do it anyway in Java. So we just keep storage, cheap storage, and you can use plain files. You can use blob store like S3. This is very cheap. And so this is a plain architecture, very simple to build and to test, to deploy, to run. We can also replicate the object graph through hundreds or even 1,000 JVM processes, and then a cluster structure gets also very simple. So we replace the JPA nodes with EclipseStore nodes. We replicate all of these nodes, so we don't need a distributed cache anymore. We store data in a binary blob store, like S3 for instance, and then we have a plain architecture. And you can also query such a cluster by using REST or GraphQL from outside, very easily. So, and how to get, and how you code all of this, Christian will introduce you to how this works.
Okay, great. So, live coding is sometimes a mess on a conference or on a talk, but we will give it a try. It's yours. Okay, thank you, Markus.
Questions?
As much as you can. Okay, let's move on. Give me just a few seconds to start. Okay, I brought 3 products for you. One is a very basic one, just to show you how it is to work with EclipseStore, and there are only a few lines of code you have to know. And then we got a little more advanced one, and at the end we jump into the cluster itself, and I will show you how the cluster basically works and how to create a cluster, and so on. So, but yeah, let's start with the basic project. And by the way, you can find any example or every example I showed you on my GitHub account. I will share the link later on. Okay, first, what we need at startup, for sure, we need a dependency. So this is dependency which is available now, especially from, okay, now you can see it, right? So, okay, great. Yeah, we are here at the POM XML, and you see this is the dependency, which is the current one. It's still on MicroStream, but as soon as EclipseStore is final, then you can change it to EclipseStore version 1.0, and the API stays barely the same. There are some difference on the imports, but the API itself, it's the same. There are many more dependencies. You could find all of them within the documentation of MicroStream. But for the first start, you just need this one. Okay, we got this. Next step is we need, at least one customer, one normal Java bean. So this is what we want to store, and we need another bean, which is called company. So in my specific example, so I have one company in my application, and this company contains multiple customers. And this is what I want to store. And with EclipseStore, it's quite important to have one root node on top of the graph. So we need just one node, and in my specific case, it's the company, and the company contains all the data below. So that means we need one root entry point to our graph to stream through and get to the collections. But yeah, at the end, the company is my root object in that case, and the company contains a list of customers. And for those of you who are asking, okay, what kind of data or collections could I use within EclipseStore? You could use everything, not only lists and sets and something else. You could also use hash maps and stuff like that, especially for creating indexes and so on. It's totally up to you to create a data model which fits best to your application or to your application needs. Okay, so what we need is, this is my main class with a normal main method. As I said, it's just a very, very basic example. And there are two important objects we need at the beginning, and it's totally up to you to initialize the storage manager. This is the first important object we need to initialize. It's we call it storage manager. It's kind of like let's say the database management or the storage management system. Whenever you want to access to your storage and you want to store something, just call the store manager. And we need one root. This is our main entrance. I've already explained that. This is the company which is needed within the storage. So this is how you can initialize a storage manager. And you see there are two parameters that I hand over. The first one is the root itself. So we already talked about that, the company object. And I have to define where the data should be stored. And in my specific case, I directly stored it to the hard disk. And in my case, it's a data folder. We will see that later, that the data folder occurs directly after starting the application. So what else do we need? So we need, of course, we need two customers that we want to store. And I have to add these two customers to my customer collection of the root object. And that's important, within EclipseStore, you always have to store the object which has changed. So maybe you're used to store the object itself. So let's say with a relational database, specific with Hibernate and so on, mostly you call a save method on the object which is created. Yeah, so when you create a customer, you will call customer.store. But it's different in EclipseStore. You always have to store let's say the parent or the owner of the object or the reference holder, I would say. And in that specific case, the reference holder of my customers are the list of customers itself. So whenever I add a customer, I have to store the list in the end. So this is how it basically works. Yes, and this is done here. So I stored the customer, and this is just for see what's going on. So we see that the two objects are created, and let's have a look to the console. So let me just start this, and let's see what happened. Okay, now, yeah, you see, these are the two objects we created. But yeah, this is nothing special, I would say. So let's give me just the possibility to refresh the project. And this is what happened then. This is the data folder, which is created after starting the project. And you see there are two files in it. One is the channel 0 file. This is the folder which contains the data itself, the binary files. And there is another important file which is called the persistence type dictionary. And the type dictionary contains every object definition of the database itself. So that means if you open that, you will see longs and integers and stuff like that. And also you will see our customer object. It's kind of like the definition of the object which are part of the storage. Okay, so this is created. So now let me remove these lines. We don't need these lines anymore. Of course. There are two files. The first one is the .dat file. It contains the data. And there is another one which is a transaction file, but this transaction file is only used for internal stuff within EclipseStore. Sorry. Okay, let's start this application again and see what happened if we marked out this and let's start it again. And you see there is the data again without creating it. And this is because the data is already stored to the hard disk, and it is part of the .dat file we could see here. This is a very, very basic example how EclipseStore basically works. And yeah, that's all you need to know, I would say. First example. Okay, so if there are any questions, so feel free to write it down to the Slido. Let's move on to a more advanced project I have brought. It is the car exercise. So in that specific case, I created a small Micronaut application because people always ask, okay, is it possible to access the data from a lot of applications around, so different applications? And we always say, no, it is. And this is on purpose because in the future, or in the past, I would say, a lot of people access one storage in the middle from a lot of different applications and gets the data out of it. But this is not best practice, right? So there are different business logic within, and something could go wrong. And so, and the best practice is always there is only one application which accesses the data and provides the data via REST. That's how it should basically be the case. And therefore, we always recommend to say, okay, if you need to access the database from multiple applications, do it via REST or via Kafka messaging services and so on. And this is why I created this example. Give me just a second. And let's go through this to the main, to the most important classes. So what you can see here, I divided the application, some packages, and there is another structure which is based on a car and brands, and we have our company again. Let's have a short look to that classes. As you can see here, in that specific case, the company is again our root object. It contains multiple brands and multiple cars, or a collection, brands and cars, and also a name. So let's go on. Then there is another class which I called DB. And this is the same stuff we did before in the main class. A little bit different, because you see here there is another way to initialize the storage manager. There is one builder pattern which is part of the API, and that gives you the possibility to do some more configurations on the storage itself. And a specific configuration is the channel count, and the channel count defines how many threads can access your binary files or your hard disk to load the data with multiple threads. And when we start up the application, you will see there are not only one channel folder, there should be two. So that gives us the possibility to access within 2 threads the data, to load data faster from the hard disk. So we create a foundation. This is also what always happened. So when we initialize an embedded storage manager or configuration, you have to create a foundation object, and based on that, we create the storage manager. We hand over the root object, in our case the company, and then we say start, and then it should work. Okay, let's have a short look to the controller classes, which in that case, they are the most important classes, I would say. Yes, because it's all about the CRUD functionality, how to access the data and how to load it. I think that's really straightforward. So we have some methods, for example, list cars, and as you can see, yeah, we just call the collection of cars within the root object, and that's it. And it's the same on other methods here. So for example, when we want to load some data, you see, as Markus already explained, we use the Java Streams API to get the data out of the storage. That gives us possibility to filter data, to group and buy, and a lot of stuff is going on within the Streams API. And this is how basically you should access your data. But there are some more stuff. For example, when we want to clear cars, so how can we delete elements of the storage itself? And it's also really straightforward. So first of all, we go to our cars collection, then we call clear, and after that we call the store method on this specific collection. So, and this stores the data, or that removes the data directly from the storage itself. It's the same on an insert method. This is a little more advanced method, especially before I enter or before I add a car, I check if the brand is already available and stuff like that. But in the end, a car is created, I set the brand, I set the model, and then I add this car directly to the collection. It's quite easy to do. Let's start this application, give it a try. So hopefully that will work as expected. So let me just double check if the data folder is already in place. So let's delete the data folder first. And now, this was the wrong one. So let's move to the application class. Let's start it. Now you see Micronaut is up and running. Let me just double check the port. It's 8070. So I prepared the Postman car exercise. let's call the all cars method. Hopefully it's the right one. You see, it's empty because the database is just created. And when we have a look to the console, it should show the initialization of MicroStream itself. So we had the first access to the database, and it sees, okay, there is no data available, but it initialized the data. And after that, the data folder should be available within the project. Let me just check. Here you can see, this is the data folder. And as I promised, we used 2 channels. And therefore, you see the 2 channel folders, as I said, to access multi-threaded to the hard disk. So, okay, let's move further to Postman. Let's do some inserts. First, I have to insert a brand. Let's click on this. Let's do another one. Let's say Mercedes. Oh, come on. So, not working. Up. I didn't get it. So, okay. Thank you. So this is what I talked about. So let's say send. So let's call we have a list of brands. All brands is here. Let's call send, and here they are. And now we are able to add, insert a car. Yeah, should work as expected. Let's get back the cars. Yeah, it's quite easy. So as I said, this is the way how to provide data for everyone or for multiple applications. So this is kind of like creating your own database, right? So it's really straightforward and it works really great. Okay. Last but not least, we talked a lot about how to replicate data. And this was always a question to us. People ask us, okay, is it possible to replicate EclipseStore and MicroStream and how to do that? And we thought about that and we said, okay, how can we need a server, right? So we need something like to start up and that does the replication in the background and stuff like that. That is not, I would say, that is not the hardest thing, but there's always a problem because the data structure is your own data structure. So how to tell the server what kind of data should be accepted or what kind of data structure do we have? Because this is your project, right? So when you create and EclipseStore is just a framework. So we have to find a solution to create replication and a cluster based on your project, and that was the biggest issue in that case. So, and the idea was, okay, let's find some standardized stuff to do the replication, and therefore we chose frameworks like Helidon or Micronaut, and we added a specific embedded storage manager, not an embedded storage manager, a cluster storage manager, and that enables us to do the replication in the background. So that means when you want to create a cluster based on EclipseStore, you create a normal Helidon or Micronaut project with your data structure and so on. You create your REST endpoints as you are used to. And after that, you hand over that project to us, and we do the replication in the background. And then you will get a cluster. And how to do this? There is another example, which is already part of my GitHub account. So, but let's switch back to my IDE. It is called cluster demo. When we have a short look, there is nothing special in it. Let me just show you the storage part, because this is the only thing which is a little bit different. So instead of using the embedded storage manager, in this case we use the cluster storage manager, and that comes with more advanced business logic in the background that enables us to replicate the data. And therefore, we created a specific, where is it? Here is it. This is our cluster frontend. So you could access this. It's available at cloud.microstream.1. And this gives you the possibility to create your own cluster based on your EclipseStore application. I think it's there is another advantage, because you will be able to start with a small project with Micronaut, and this could run in production for sure. And after that, you say, okay, now we need a replication. We need to scale and stuff like that. Then you can hand over this. You need slight changes, but after that, you are able to deploy that within our cluster. And this is what we can do here. So there is the possibility to add a cluster. And as you can see here, it enables you to choose any basic architecture you want, and also the provider, AWS, Google Cloud, or Azure. And in my specific case, I use AWS with the region Europe. And then let's say next. And then here I'm able to choose a specific tier, I would say. That means, for an example, I want to have 2 replicated nodes in that case, and it's always a single master replication. That means we have one node, which is the writer node, and we have multiple reader nodes. So we choose the node. We are also able to provide an auto-scaling functionality. That means whenever you need more nodes, it scales up, and if you need less, then it scales down. Okay, say next. So then we have to create a cluster name. Let's call it GeeCON, for example, or GeeCON cluster. We have to choose the application type, whether it is a Micronaut or a Helidon application. And after that, you have to choose the URL, where to find the application, specific the URL to your Git repository. Or you will be able to upload a jar file. That's also possible. And let me just a short look. Cluster demo. Let's copy this. At the main branch, we have to know what branch is it. Let's say next. Then there are some more advanced features you can adjust. For example, a specific backup strategy, how to backup or store the data. Then we could add a specific cluster authentication and also an AWS private link. So when you have an AWS infrastructure within your company, then you will be able to use the private link access. That means the data from this specific AWS account doesn't go through the internet instead of going directly to your application within a private network. We don't need that now, so just skip that. And then there is another point, it's the routing. There are specific way how to route the data, how to ensure that writing data goes exactly to the writer node. There are 3 different strategies. The first one is we use the normal HTTP methods for that. So that means every put, post, delete, patch goes directly to the writer node, and all the other requests go to the reader nodes. But there is also a possibility to add some specific URL to the path to know whether it is a writer or a reader request. Or we could also use some specific header values of the request, and that makes the decision where the request should go in the end. Okay, after that we are able to create. I have done that before, so there is a cluster still available. It looks like this, and it's the same cluster I created before. And let's have a short look to the details of that cluster. You could see everything what's going on within inside the cluster. As I said, there's a cluster with 2 nodes. So we have node 0 and node 1 here. And there is one writer proxy which makes the decisions where the request should go. And there is another one, there's another proxy before, and like I said, it makes the same. So these 2 proxy nodes take care of the traffic within the cluster. And that enables you to see what's going on the cluster, how many workload on CPU do you have on your nodes and stuff like that. You will be able to make changes there, to adjust your backup strategies. There is some more monitoring stuff to see, okay, what is CPU load on my machines and so on. We have an embedded logging, so that gives you the possibility to see all the logs of the nodes and see what's going on the cluster. I think that's all stuff. It's very useful to see and make decisions and how to increase the nodes, for example, and so on. Let's try to, at the end, you see the URL here on top. So let's copy that. And I would say it's the same. We can call it via the Postman now. Where we are, cluster calls. I already opened it here. Yeah, you can see this is my the demo, and I'm able to call the list. Let's just send, and you see this data comes directly from the cluster I created before. Yeah, normally I shared always kind of like a performance demonstration, how fast it is and how it is. But for today, it's not possible. The network is not that good, and I'm not able to send that much requests to see something on the cluster. So that means it's not possible. Yeah, but as I said, I prepared a specific performance demonstration, and let me just explain that a little bit. So at that specific case, we created, or we have two EC2 instances. At the one, there is EclipseStore running on a Micronaut project, I guess. And yeah, it provides REST endpoints. And it's the same on the other side. There is also a Micronaut application which is connected to a PostgreSQL database, which is on the same machine. So that means both applications are writing data directly to the hard disk and working on that EC2 machines. And there is a third one, and the third one makes requests to that machines. And now we are able to see what's going on. Let me just start this, and this is the first example. It's just a database which contains around 1,500 books with values, title, author, ISBN, and so on. And let me just start this. And this is a really straightforward query, I would say. Just give me that 1,500 books with a few amount of values. When we now have a look to the Grafana board, which measures all the performance of the two EC2 instances, we would see the result at the end and how many requests we get and how long does it take to, how long does the response take. Just a second, it needs a little bit to measures the average. So some of you might say, okay, does it make sense to compare EclipseStore to a PostgreSQL database? Well, of course, EclipseStore or MicroStream is an in-memory database, but what about PostgreSQL? There is Hibernate in place, and Hibernate, the caches of Hibernate are enabled, so that means both applications are getting the data from a cache, of course. Then, in my opinion, both should be same fast, I guess, right? So, but there is a big issue on data mapping. Mapping is quite slow, and this is also the point. So you see, 1,200, this is the maximum we can send, and it's interesting to see what CPU we have on that machines. We have PostgreSQL on 74, 71% on CPU, and we have MicroStream EclipseStore with 3.68%. That's quite nothing. So that is really great. And we have also the same average of RAM usage. Why is that? Because, so I would say, okay, MicroStream in memory, I understand it's 41%, but PostgreSQL, why is it that high? Yeah, because of the caches. So you need the same caches on the application server side, and that makes a difference if you have MicroStream or PostgreSQL. You need the RAM at the same time. And the point is, the more concurrent user you have on your application server, the more RAM you will need because the more data is loaded from the database. Okay, that's really great. So we have that much difference. So I think that's important to see. And we could have more requests than 1,200, but the sender application is not able to send. What happened if we choose a bigger call? Let's do some joining stuff, and let's join the books and authors and stores and so on. Let's start this. And now you would see that both applications are on the CPU limit. This is the right one. Just give it a second. Now you will see both machines are running on maximum CPU because both machines have to work really heavy, but the result is totally different. So you will get an insane amount of performance more on the MicroStream or EclipseStore side. That is really great. So you can see how fast it is. I think there is a lot more we could talk about, and if you want to know more about EclipseStore and MicroStream, just visit our booth, and we could also talk about that performance demonstration. Yeah, I'm really looking forward to talk with you to this. Okay, there are 10 minutes left, right? Yeah. So now it's...
Sorry for interrupting, but we had a lot of questions.
Yeah, okay, so let's jump to the questions where they are. It's Slido, right? So
there, for instance, is a question: how do we handle schema migration? So this is a big topic, and we have functionalities called legacy type mapping, and this is actually very simple. So each time the engine loads an object, your object gets compared with your class. And if there are some changes in the class, then the engine can handle this automatically behind the scenes with a heuristic. So if you add a field, remove a field, rename a field, and even some type changes can be handled automatically. For more complex cases, you can define a legacy type mapping. Then you store your object again. Then you have two versions of your object in the storage. So, and there is another question in terms of can I keep all the versions? Yes, you can keep all the versions because all objects are stored appended to the file storage in any case. So even if you delete an object, remove an object from storage or change an object, we store it appended to the file storage. There is a kind of like garbage collector, so EclipseStore provides a garbage collector for the file base, and you can configure that. You can let the garbage collector remove older objects from your file storage to clean up your file storage, or you can keep your older versions. So, but keep in mind, this is not comparable to event sourcing. We store the state, we do not store the event. But you can keep older versions, that's true.
So there is another one. Let's jump this. I mean, I think this is a little misunderstood. We didn't store the diff only. We stored the whole object again. So that means when you change a customer, for example, the last name, this customer, that specific customer will be attached to the end of the storage. And at this time, you have 2 times the same object, the old one and the new one, and the garbage collection removes the old one. That is what Markus explained. So this is not only a diff, it's the whole object which has changed at that time.
Diffs in terms of huge collection, for instance, if
you
have
right.
a huge collection, you change a single object, we never would store the whole collections again, then only diffs are stored to make it more efficient.
Okay, so then we can talk about a little bit of use cases. That is a great topic. So there are a huge amount of use cases, I would say. No specific ones, but there are a lot. So we talk about, for example, the easiest thing, storing mock-up data for testing, for example. That's one big use case. But there are also use cases where we just don't want to use any MySQL or PostgreSQL databases for smaller and medium-sized application. That's also really great. But there is also a use case for microservices. Whenever you need a storage which is lightweight, when you need the performance, that could also be fit on your 1 terabyte Oracle database. As I said, there is no specific use case, but do whatever you want with that storage, and that is really great. That is, I think it's kind of like a dream come true to store the data directly with Java without any database anymore. So I think it's totally up to you to find the right use case that you want to have. So.
Yeah, it was built to store objects persistently on disk. So it's very generic, so similar to what Hibernate is actually doing. Yeah, you want to get persistence for your objects. And by the way, you could see that using it is very simple. There are no specific requirements to your classes, no interfaces to implement, because there's also a question about serialization. We didn't use, obviously, the Java serialization. It would be not possible with Java serialization, so this was the reason why we wrote the Eclipse serializer. It's a completely different approach of serializing objects. You can deal with really complex object structure with circular references. This is covered by the Eclipse serializer. You don't have to use super classes so really pochos, and you can design your model freely.
And there was a question, what is free and what is paid? The framework is open source and free. You can use it whenever you want. And paid is the cluster we talked about. This is a paid thing. There is, many people ask us, is it possible to have the cluster also on-premise architecture? It is. Just give us a call. We try to find a solution for you. You will be able to have this on-premise also. This is what you have to pay for. But the framework itself and the basic usage of EclipseStore is totally free. So, yeah, that's also a good question. How do you handle which objects from the graph are loaded in memory? I think there is one question which is very similar. It's the lazy loading question we have here. So we are able to set specific points of lazy loading. It's kind of like a wrapper object. So that means it looks like lazy, and then you have that brackets, and then you see list of customer within that lazy. And everything what is designed lazy, it stays on the hard disk as long as it is needed. So for example, let's imagine we have a huge amount of customers, for example. You could create a hash map or a huge amount of books, for instance. And then we have on the key side, we have, yes, let's say the first 3 digits, the first 4 digits of the ISBN, for example. And then we have a lazy list of books on the value side. That gives you the possibility to say, okay, I don't have to load the whole list of books at once when I want to stream through. So you use the index to find the right collections, and then you have to load the collection, then you can search within that. That is how it basically works. But yeah, in short terms, lazy loading, there is a lazy wrapper class, and that data stays on the hard disk as long as you need it.
And when you start the application instantly, then the engine loads the whole information of the object graph, and you get the representation of your object graph in memory of the whole object graph, but only the object IDs are loaded. If you have use only lazy loading, then no data would be loaded. And if you access your object graph by calling a get method, then the object reference is loaded into memory and is merged into your object graph automatically. So there is no difference between get an object from JVM or from the engine, from the EclipseStore engine. So it's fully object-oriented, no more classic selects. So this is very convenient. And there are also a question about ACID transactions. Mm-hmm. So you have to be careful. So your object graph is your memory database. So you change the object graph, and then you should, it's not mandatory, but you should persist your changes on the object graph. And by calling a store method. And this store method, this is an all or nothing atomic operation, and it's transaction safe. So we have a transaction journal that we can make sure that all stores on the storage are really transaction safe. But it's not a database server, so don't compare this with transactions in terms of a relational database system.
So another question, do you have benchmarks against different cloud and storages? Of course we have, internally, definitely. But the question is if we should publish that. I mean, the point is that every solution on the market has its own trade-offs and its own benefits, I would say. And sometimes it makes no sense, specifically when we want to check if we are faster than the other solutions. But you have to imagine whenever we talk about, let's compare, for example, MongoDB with EclipseStore. So when you store something to MongoDB, you always have to convert the data to JSON, and that's need time and that needs performance, and we don't have to do that. So we use the object as they are. We don't have to convert the data to, and that gives us a big advantage in terms of performance, I would say. But yeah, there are benchmarks, but they are not published. So because sometimes it makes no sense to do that.
One important question is, we answered this actually already, but it's super important. So what if my database does not fit in the memory? We have this lazy loading. So if you have enough memory, please use it. So it's in-memory technology. But if you have 500 gigabyte database and you only have a 4 gigabyte memory, this will work. So then use lazy loading, and you don't have to care for memory management. You have full control of your lazy references, so you can clear up your lazy references in memory. You can let the JVM do the job, or you can define timeouts, so we have full control of this. So this will also work with lambdas, for instance, so only 500 megabytes. This will basically work. But it's the same with other approaches. So most people say, my application nodes should be very small. Yeah, we have to save memory money. On the other hand, you use a big monolithic database server with tons of memory, or use in between a cache cluster. So if you have a memory, so we save a lot of memory, and computing, so we don't need a database cluster anymore, don't need a distributed cache anymore, so use it in your application nodes, and then your application will be super fast. But it's not mandatory.
So there are a lot of more questions, but I guess we're running out of time. But I'm really looking forward to answer that question on our booth. There are still M-size T-shirts left you can have. There is still our raffle is still available, so we have 4 prizes that will be raffled at 4:10 today. So if you want, fill out the form, and let's talk about your questions on our booth. Yeah, I'm really looking forward. Thank you from my side.
Thanks for joining. Have a great day.
Have a great day.
Thanks.
Bye-bye.